Hello and welcome. Thank you for joining us today for this session. These are very exciting times indeed for data professionals like us. We have never seen this level of data growth in the history of computing. From just 2010 to 2020, the total amount of data captured worldwide grew 50 times. 90% of the data that's in existence today was created in the last 2 years, and there is no slowing down. The amount of data generated, collected, stored, analyzed, and acted upon is only going to grow exponentially. Improved connectivity worldwide, along with the new generation of IoT devices and sensors, are major contributors to this unprecedented data explosion. Your mobile phones and smartwatches are constantly generating and capturing data. Every mouse click online and e-commerce transactions are data points captured. Thousands of sensors in vehicles, medical devices, industrial machinery, and even household equipments are constantly streaming data. Higher bandwidth, lower latency networks like 5G and later 6G will continue to propel this data growth at even higher scale. But how do we really make good use of this data? It's interesting to know that 73% of the data available today is not being analyzed or put to the right use. Just generating and capturing data is not enough. We need highly scalable, performant, and cost-effective systems to be able to properly store, manage, and analyze data. The scale of the growth of data and ever shorter time frames the data operations need to be conducted makes cloud-based data solutions the best suited for this purpose. And it's also a proven fact that companies that embrace cloud services see substantial improvements in time to market, growth, and overall efficiency. So it just makes sense to use cloud-based solutions for all kinds of future database or data analysis or data usage related workloads. Now, when it comes to databases in the cloud, Azure SQL continues to be the leader with unmatched security, cost performance, and a wide range of offers that covers all customer workload scenarios. In this session, we will take you through a journey to see how our customers are using Azure SQL, various design patterns they're adopting, and different components and features of Azure SQL that helps them achieve that goal. I'm Abdul Sattar, and I have with me my colleague and dear friend, Sanjay Mishra.
Thank you, Abdul. Good morning, good evening, good afternoon, everyone, depending on where you are. I'm very excited to be here with you today to talk about how customers are using Azure SQL. Before we dive into various types of customer workloads, let's take a look about what offerings we have in Azure SQL family. Azure SQL family offers you two types of services, either a platform as a service where Microsoft manages your service, either a database or an instance, patching, upgrades, backup, HA, everything is being taken care of in the PaaS service for you through Microsoft management. Or you could have a VM and you could manage it, what we call as a infrastructure as a service. And we will not have time to go into details of each one of these flavors, but be assured that irrespective of which one you choose, you are picking the industry leading database on best performance, best security, best high availability, and best SLA across industry. I encourage you to go and attend this session by my colleagues, Ajay and Anna. They will be talking about what to use when and what's new in any of these services. Now let's look into the various workloads that you typically observe across customers. When it comes to database workloads, you could see a spectrum of workloads. On one hand, you could see millions or thousands or hundreds of tiny small workloads which expect very low latency, high throughput. On the other hand, you could see very large databases where you may be running a few analytical queries. And real world workloads probably have a mix of a bunch of these characteristics. What we have done here is we have taken a look at a variety of customer workloads and classified them as 6 classes to give you a sense of how customers use Azure SQL. And these will be we'll be looking at high throughput and low latency workloads, for example, IoT or gaming or stock trading kind of workload. Or we could be looking at a mission critical workload. Maybe you are running a hospital, you are running a retail, or you're running a business for which your database needs to be extremely high available. And you could be a SaaS provider, which means that you serve thousands and thousands of your customers, which means that you need a scale operation to serve those databases for your thousands of customers. And then, irrespective of type of workload you have, you always need to choose the best elasticity and scalability to achieve the best price performance combination for your workload. And we'll talk those kind of scenarios as well. A new type of scenario is evolving these days where customers are trying to combine transactional workload along with analytical capabilities. And we'll showcase you how the power of Azure SQL can be very handful for those kind of workloads as well. And if your database is successful, if your application is successful, you will see that you have more and more data coming into it, which means that your data has seen exponential growth. As you saw at the beginning, Abdul gave you certain data points on how data in the world is growing, which means that we need to be ready for very large databases in Azure SQL as well. And we have some awesome offerings that we are going to showcase you. To start with, let's start with a high throughput and low latency workload. And we're going to showcase this workload through an IoT workload. IoT workload, Internet of Things, as you can see, it's a very prevalent workload these days. And what we expect here is that there are thousands and thousands of events or sensor readings are coming into database through various layers of processing. This is a typical product agnostic architecture diagram for an IoT application where the sensors or edge devices deployed in field could be your manufacturing conveyor belt or could be a power meter or could be anywhere, and or could be weather reading from some cases, and they are sending data through a cloud gateway through some kind of intermediate processing into some storage. And Azure SQL is an awesome place to serve as a warm storage for IoT applications. And double clicking on this, you can see the various products in Azure ecosystem. You can use them to build an IoT application. IoT devices through a gateway, through data coming into Azure SQL database and then being used for analytics. For today's purpose, we'll talk about this path where in the warm path data is coming into an Azure SQL database. Let's take an example. Let's do a demo that will make things even more clear. The demo I'm going to show you today is about a smart grid power meter. This is a map. You can see the red dots represent the power meters. These are actually electric power meters installed at residences, in buildings, on businesses, where the electric power utilization is being read by these meters, and they're sending these meters to a central hub. And the central hub is actually a cloud database, which is Azure SQL in our case. Um, Given the thousands of these power meters installed, they send humongous amount of data into the SQL database at a very, very fast rate, and they expect very low latency performance. Let's take an example and then see how much SQL can scale. What I have here is actually an application that I'm going to start, which is going to simulate power meters that we showed on the graph on the map. And these power meters are going to collect and send data at a very high throughput rate into the SQL database. And let's see how much this SQL database can keep up. And as you can see, it starts from 0, and very soon it's able to send 2 million rows per inserted into the SQL database at this time. And as you can see, it's growing, and it can scale further and further and up. 3.8, 3.94 million rows a second being inserted into the SQL database. How are we able to sustain this kind of a high throughput workload? The magic of this is actually in the database design, because Azure SQL comes with some very good capabilities to be able to sustain a low latency, high insertion rate. What we have behind this is a SQL table in the database, which is designed with memory optimized and durability schema only. As you know, Azure SQL provides memory optimized tables and memory optimized store procedures. We'll talk a bit more about that later as well. And this allows you very fast data ingestion, because it can give you no IO, because we are using schema only, no locking, no latching, very fast data insertion. However, because this is schema only, this is this data is held in the memory, which means that you want to make it durable. To make it durable, what we have behind the scene is the data being captured from the memory and put into another table. And that table is designed with column store index. It's a clustered column store index, which means that ingestion into the table will also be fast. And the second thing is that this data will be compressed and very useful for your subsequent usage. And through this design pattern is called shock absorber pattern, through which we are able to actually achieve a very high throughput rate of, and this is a pictorial representation of how data is coming from the sensors into the memory optimized table and then being offloaded into a column store optimized table. Now let's go back and take a look at how our insertion rate is growing. As you can see, it has reached 4.5 million rows per second. Looking into the resource uses of the database, let's take a look into how our resources are doing. And you can see we are pushing, this is a DMV that can tell me every 5 seconds how much of CPU, IO, log, etc. I'm using. And I can find that I'm pushing it pretty hard. I'm using 80%, 90%, 88% of 94% CPU, which means that I'm utilizing my database to the fullest, which is great, because I'm able to drive my database capability. No, I'm not bottlenecked by any other resource constraints. Now, as the data is coming into, I have an urge to go and look at how the data is coming because I want to know, is there a faulty meter somewhere, because maybe I did not receive data from a meter, or maybe I received an outlier number from a meter reading. So to do that, I need to query the database. Now, so that I do not overload this database by my queries, what I'm going to do now is going to run my query on a read replica. Uh, this is a business critical tier of Azure SQL database, which comes with a free read replica. And later on, Abdul is going to talk about the various architectures, how these read replicas work, and how they together provide you high availability at the same time about a free read replica. But for the sake of the demo, what I'm going to show you is that I'm going to kick off another workload that reads data from the read replica. To connect to the read replica, I connect with application intent equal read only. You are very likely aware of that. And using that, I'm using a similar console application, and this is just reading data from the database. And as you can see, I'm able to read thousands and thousands, hundreds of thousands of rows at the same in continuously without impacting my insertion, which is going at a very steady rate. So this is an awesome example of IoT workload being served by Azure SQL database. Let's take a look who is using it, because many customers use this workload pattern on Azure SQL database. RXA Realty is actually one of the biggest real estate companies in Manhattan, New York. They actually provide real estate for businesses in New York, and they own real estate in some of the most popular and most important buildings in New York City. However, offices has been closed because of the lockdown. And then after the lockdown, when the offices started opening, RXA Realty wanted to set up some automated system so that they can actually monitor the density of people in the buildings, because they don't want everybody to come in. They want only limited people to come in so that they can maintain social distancing. They don't want anybody with symptoms, with fever and everything to come in. So they actually install cameras, including thermal cameras, to take temperatures of the people, various places in the building, including at the gate. And through this process, they have actually built this application called RxWell in partnership with Microsoft Azure, and they are actually using this as an IoT system, sending this camera information through IoT Hub, eventually arriving in Azure SQL database, and thereby providing them the capability to monitor the building density, monitoring people's health, etc., etc. I encourage you to take a look at the full customer story here. At the same time, this story also includes a video of detailed architecture on how they built this application using Azure components. So very useful reference to read. Moving on. Um, the next application pattern that we want to talk about is actually mission critical workloads. Over to you, Abdul.
Thank you, Sanjay. Now let's look into the reliability and availability features of Azure SQL that are put to use by our customers for their mission critical workloads. High reliability and availability of database is indispensable for mission critical systems. At the end of the day, database is the most critical component of the system. So it's crucial that the database is extremely resilient to failures. This requires multiple levels of protection. Protection against hardware failures, failures of data center itself, as well as failure of the entire region. Building such resilience is quite complex and maintaining it is pretty cumbersome, but you don't need to worry about it because we have abstracted all that complexity from you. You can launch an Azure SQL database at the desired level of resilience with just a few clicks, and we take care of everything under the hood. There is redundancy built into every level of our service. At the minimum, data is replicated across 3 storage systems. Equipment failures are instantaneously detected within a data center, and failed instances are automatically reprovisioned on the buffer capacity available within the data center. All applications are not created equal. We know that some of your applications are more critical than others. The level of resilience and availability needed for these applications also vary. This applies to different environments of the same application as well. Resiliency and availability needs of production environments and development environments are not the same. That's exactly why we have a range of offerings with different levels of resilience, availability, and performance. For example, our business critical offering comes with 4 simultaneous computer instances and related storage system replicated synchronously, whereas our general purpose offering comes with a single compute instance with 3-way replicated Azure storage. You can choose additional options on top of this to make your database have even higher availability and reliability. Let's see how that can be done. Zone redundancy provides your database higher availability. Many Azure regions have multiple availability zones now. Availability zones are unique physical locations with independent power, network, and cooling. Each availability zone is comprised of 1 or more data centers. While Azure regions are farther apart, availability zones are a little more closer to each other, making it possible to have synchronous replication. In the previous slide, I explained how we provide immediate replacement for database instances in case of equipment failure within the data center. But what would you do if an entire data center goes down for whatever reason, like lightning strike? You don't want your mission critical application to be down. This is where zone redundancy comes in. In zone redundant configuration, your database will be synchronously replicated across 3 availability zones. In case of a data center failure, we'll instantaneously fail you over to a data center in another availability zone, and your business continues like nothing happened. In zone redundant configuration for business critical, the 4 replicas of the database are placed in 3 different availability zones. Zone redundancy for business critical is now available in all Azure regions with availability zones, and there is no additional cost for this feature. Now, for our general purpose offering in zone redundant configuration, the storage is distributed across 3 availability zones and kept fully synchronized in real time. In case of a data center failure where the database instance is running, a new instance is brought up immediately within the reserved capacity set aside in the other availability zone using the same storage that is distributed across the 3 availability zones. Zone redundancy is in preview for general purpose, and there is a cost associated with this due to replicated storage and reserved capacity. As you can see, for a mission critical application, zone redundant configuration provides you higher level of protection and higher availability. Well, we covered equipment failure and data center failure. But what would happen if an entire region goes down? Let's say due to a natural calamity like earthquake or flood. Most businesses these days are global. A natural disaster in one area of the globe shouldn't disrupt the business in the rest of the world. This is where disaster recovery comes in for business continuity. For this, we use active geo-replication, which allows you to continuously replicate data across regions and have secondary database instances ready and available in case a disaster strikes and an entire region goes down. In this case, data replication is done in an asynchronous fashion. Since this is an asynchronous replication, at any given point, the secondary data might be slightly behind the primary database, but the data is guaranteed to always be transactionally consistent with changes committed to the primary database. You can initiate a failover to any of these secondaries at any time you want. In addition, active geo-replication can also be used to support your application level functions like upgrade and patching or relocation scenarios. Since all of these secondaries are readable, they can also be used for read-only workloads. Remember, I said you can have up to 4 secondaries. You don't have to have 4 secondaries. You can have just 1 or 2 or 3, or you can have 4. You can also have even more secondaries by doing something called chaining. Now, auto failover group is built on top of geo-replication. Auto failover groups is the diagram that you see on the right. It allows you to create a collection of databases that needs to be failed together in case of a disaster. So when the disaster strikes, or if one database goes down, you don't want just that database to fail over, because there are dependencies between these applications or databases. So you want a collection of databases, all of them to be failed over. That is where auto failover groups comes in. And auto failover groups also allows you to set up automatic failover when a failure is detected in the primary. You can still do a manual failover if you like. Now, by definition, mission critical application needs to be continuously available. Using zone redundant database along with geo replication helps you build the required resiliency and availability into the database component of such applications. But to achieve real business continuity, adding increased resilience and availability to the database is not just enough. It needs to be done to every component of your overall application architecture. Service level agreements or SLAs give customers the confidence to use the service for their most critical applications. I'm happy to tell you that Azure SQL has the highest level of availability SLA of any relational database service on the cloud. Azure SQL Database Business Critical or Premium tiers configured as zone redundant deployments have an availability guarantee of at least 99.995%. We also have the only business continuity SLA in the industry. Now, when I say business continuity, it's about DR or disaster recovery. That's what we discussed in the last slide about geo-replication and availability groups. Now, when it comes to geo-replication or disaster recovery or business continuity, nobody else has an SLA. And our SLA is 5 seconds RPO for business continuity, this is for the business critical tier, and 30 seconds RTO or recovery time objective, again for the business critical tier. Paychex is a great example of a customer who is running an extremely mission critical application at very high scale on Azure SQL. Paychex is a human capital management or HCM firm with a tremendous reach. They serve more than 650,000 businesses across US and Europe and pay 1 in 12 private sector employees in America. Now, we are talking about massive scale and a very, very mission critical application. And payroll processing is as mission critical as it gets. If you don't process payroll on time, you're not able to pay your employees on time. That causes employee dissatisfaction. And then there are regulatory issues. If you're not able to pay your employees on time, there could be, union related issues. They could be, fines and whatnot. So being able to capture the time card right on time and process the payroll right on time, and then as a high scale business, being able to continuously grow in the number of customers and number of their employees that you're serving, the scale of growth and the elasticity required for doing that is great as well. So now, if you think about it, a lot of what we were talking about when it comes to data explosion actually directly applies here. Now, one of the key components of Paycheck Flex Suite is a Paycheck Flex Time, an app used by millions of employees every day to clock in and out of work. FlexTime handles 13 million time cards and 3 million distinct punches on any given day. Punches come from a myriad of sources like worksite, kiosks, mobile phones, desktop browsers, and more. And each is processed in less than 2 seconds. So a lot of what we talked about in the beginning of this session directly applies to Paychex. And when Paychex actually started thinking about moving to the cloud for the scale and the performance and the business continuity and availability needs they have, they didn't have to look any further than Azure SQL. Now let us take a look at running SaaS applications on Azure SQL. There couldn't be any other application that would require the kind of scale from the database that a SaaS application would require. There are a lot of things that make Azure SQL the perfect database for SaaS applications. Some of them are the level of automation available in Azure SQL. One, it abstracts a lot of complexity away from you, so you don't have to worry about, the mundane things that the databases need to do. We take care of all that for you, and pretty much all of it is automated. Now, in addition to that, because of the level of sophisticated APIs available and the use of standard T-SQL, and the ability to script using ARM templates, there are a lot of automation, custom automation that you can build on top of what we have built to suit the exact needs that you have for your application. Then there is Elastic Pools. Elastic Pool is a huge differentiator for Azure SQL. Nobody else has anything similar to it. Elastic Pools allows a SaaS provider to load balances resources between different customers to optimize customer performance and, more importantly, cost. So when it comes to running SaaS applications, every penny matters just because of the sheer scale of operations that you will be doing. Now, Elastic Pools allows you to bundle a bunch of databases within a single pool and then share resources within the pool. So you can intelligently bring together databases belonging to different customers or different applications or different environments that require peak resources at different point of times of the day. Now, choice of isolation levels, depending on the application architecture or customer's preference. Different customers need different isolation levels. A small business or a startup might be perfectly fine with sharing their database with thousands of other customers of the SaaS application. But an enterprise customer or a financial or pharmaceutical customer might want to have their own database. Now, because of the various models and the variety of offerings that we have, you can, for the same application, you can have multiple offering from a database perspective. You can provide customer a combined experience using SQL DB or have much higher isolation using SQL MI. Now, the security is the best in the industry when it comes to Azure SQL, and we discussed about SLA. Again, best in the industry, SLA for both availability and business continuity. That in turn allows you as a SaaS provider to turn around and provide your own level of SLAs to your customers confidently, because on the other side, we are providing the availability and business continuity SLAs that you can depend on. A quick look at the most prevalent database patterns our SaaS customers use. Starting from the left, the first one is a multi-tenant application with a single multi-tenant database. So all the customers and all their data goes into a single database. That's a very simple architecture. There are ways to prevent customers accessing each other's data for security reasons. But the one drawback here is horizontal scaling is quite limited. So if the application is small and number of customers are small, this fits pretty well in the bill. The second pattern is an extension of this pattern where it's a multi-tenant application, but multiple multi-tenant databases with partitioned customer data. So different customers go into different databases based on an algorithm decided by the SaaS provider, based on some patterns like customer names or the states they belong to or the start date of their business with the SaaS provider. This again have the same isolation issue as the first one, but it actually gets over the issue of horizontal scalability. Now, as the number of customers increase, you can just keep adding more databases to scale horizontally. The third architecture or third design pattern is one of the popular design patterns where you have a multi-tenant application and multiple databases, just like the second one, but in this case, each database is dedicated to a customer. That provides better isolation of the customer data while providing you unlimited scalability horizontally and vertically. Now, the other thing this pattern provides is higher control for the SaaS provider on the resources that are allocated for the database for each customers. All customers are not equal. Some customers might have a lot of workloads. They might need a 40-core database, whereas a smaller customer might need only a 2-core database. This design pattern allows you to do all of those things and have better control over the resource allocation. The fourth pattern is obviously single tenant, single dedicated database. And this is a fully isolated for each customer. There's no data shared in the database, and application level also is isolated to provide customer the best level of isolation possible for a SaaS application. Microsoft Dynamics 365 is one of the world's largest SaaS providers, and they're one of Azure SQL's largest customers. They're a great example for the scale that can be achieved on Azure SQL. Dynamics 365 uses more than 1 million databases on Azure SQL. More than 1 million databases. Think about how complex it would be to manage and monitor and provision this many databases that are used by millions and millions of their own customers. Now, Dynamics 365 actually achieves management of such a large fleet of databases with an automation platform that they built on top of the automation Azure SQL provides, which is being used, managed and maintained by just 2 engineers. That is the level of sophistication in automation that's available in Azure SQL. One of my colleagues, Silvano, recently wrote a blog about how Dynamics 365 uses Azure SQL. It's a great read. Please look it up and read yourself. For any kind of application that you're running on the cloud, one of the best promises of the cloud is the scalability and elasticity. Now, what does scalability and elasticity get you? Basically, on-demand performance. So you don't have to invest upfront in what you don't need all the time. Typical database workloads follow a 80-20 rule, which is 80% reads and 20% write. So one of the ways to easily scale your database or horizontally scale your database to offload the read workloads. As I mentioned before, the premium and business critical tiers, we provision 4 replicas every time you provision an instance. One of these 4 replicas is available to you as a read replica, and it is automatically enabled and made available for you, and it is part of the package, so there is no additional cost to it. When it comes to hyperscale, you can have up to 4 replicas, 4 additional replicas, and these replicas will be the same size as the primary. They are not part of the original provisioning, so there is an additional cost to it, and you have to manually enable it. But this is a great way to scale your read scaling is a great way to scale your database capacity. Now, what if you need more than one read replica? Because your read scaling requirements are much higher than can be handled by a single replica. Or you need a read scaling for general purpose database. Read scaling available as part of geosecondary is your answer. As I mentioned before, when you set up geo-replication, the secondaries that are available to failover in case of for disaster recovery are also continuously available to be used as read replicas. Now, you can have up to 4 geosecondaries when you're using geo-replication. That means you can have 4 read replicas for any one of these databases, including business critical, premium, and general purpose. Now, if you need more than 4 read replicas, you can actually do something called chaining, where you you set up 4 geosecondaries and then again set up 4 geosecondaries for one of those geosecondaries or 2 of those geosecondaries. So you can keep chaining that way and have as many geosecondaries as you want. Another really cool feature available for these geosecondaries is proximity-based routing. So if a lot of our customers are using this today for better performance of their systems. Now, if you are using geosecondaries in different regions, they are spread across different geographies. Depending on where your customer is querying the database from, you can send them to the database that is closest to them. This is not this load balancing is not done automatically by the system. You need to figure out where the customer is coming from and route them to the closest database. But this can be easily doable, and such proximity-based routing gives much quicker response to your customers when they make a query to the database they are trying to reach. Now, the cost of geosecondary is same as the cost of the primary, because it's just basically a geo replica. If you have intermittent, unpredictable usage patterns where you don't really know exactly, how big a database that you need, how many cores that you want at what point of time, serverless is an awesome option. Serverless is one of our newest offering in Azure SQL, and it automatically adjusts the resources available for your database based on the workload on the database. It scales automatically. You set a minimum and maximum resource limit. It scales automatically between that minimum and maximum resource level. And when nothing is happening in the database, it actually goes to auto pause. So, when you're not using it, you're not paying for it. All the other capabilities of SQL DB, like HA backups, automatic updates, built-in security, and perf optimization, all are available in serverless as well. This is an excellent price perf optimized solution for spiky workloads. CampBrain offers a software platform to run camp registration, fee collection, and other administrative tasks. They have benefited significantly by switching to serverless. Actually, they cut down their database costs by 60%. This is primarily because they have very spiky workloads due to various reasons related to weather and seasons and whatnot. The usage of their platform is quite unpredictable. So just handing over that task to the serverless service to decide what kind of resources to allocate to the database when They have made database management very simple for them, at the same time saving 60% on the cost. Now, during this presentation, I have discussed a few different customer stories. You can see all of these customer stories and more in detail in our case study website. Please go there and check it out. Hopefully, pretty soon we can feature you as one of the customers in one of our future presentations. Back to you, Sanjay.
Next, let's take a look of another type of workload. In recent years, a combined workload comprising of transactional workload as well as some analytical workload into the same database. These type of workloads have been recently been gaining popularity. Actually, Gartner recently published a lot of reports. They call it HTAP, Hybrid Transactional Analytical Processing. If you ask some other people, they'll call it an operational analytics. But you get the sense. You have a database where you're doing your OLTP data, and without taking that database and the data into some another data store, you want to run some analytics. Most of the real life workloads are actually fall in this category because you have some kind of reporting, some kind of analysis, some kind of query on top of your transactional data. The degree of that analysis could vary, but there is a mix in most of the workloads. Interestingly, Azure SQL is very well poised to serve these kind of workloads, and we have thousands of customers very successfully running this workload scenario. How do we do this? How do we do this is that we make OLTP faster by many database capabilities, including in-memory OLTP. During the IoT scenario, I gave you an example of how memory optimized tables and memory optimized stored procedures are being used to help us increase the OLTP transaction rate. And what we have also introduced is a column store, both clustered column store index as well as non-clustered column store index. And they provide awesome analytical capabilities. The good thing is that you can combine both these type of data structures into the same database. More interestingly, you can actually combine both these kind of data structure on the same data. And I'll give you some example to showcase how this is powerful in a real world workload. Uh, in a operational analytics scenario where you can combine the power of memory optimized tables and column stores to basically give you a joint workload. This is an example that you saw on the screen is actually a credit card fraud detection capability where the credit card transactions are coming into in-memory OLTP data store, and behind the scene you also have a column store data store where you are able to do your analytical processing to find out if any credit card transaction is an outlier. It could be a fraud or it could be a anomaly that you want to detect and you want to flag. That's the kind of application where tons of people use these scenarios. Let's take an example of how these workloads work through a demo. The interesting thing is that the example that you just saw in the graphics, we did a column store index on an in-memory OLTP table. You don't necessarily need in-memory OLTP and column store together. You can actually create a column store index on top of a regular table that you are used to. On a row store table, you can create a non-clustered column store index. That is very simple to do without changing any part of your application and achieve fantastic performance for your operational and analytic workload. Let's take a look through a demo. What I have here is actually a test workload which actually simulate lots of insertion into the wide world importer database that you may be very familiar with. It's a SQL Server and Azure SQL sample database where I'm doing hundreds and hundreds of sales order insertions. So I'll start with 250 threads, and this is going to insert bunch of, as you can see, this is the bunch of sales order into my table. You can see there is this is response time is a sub-second rate, very fast rate. I'm inserting thousands and thousands of order into my table. So this is my OLTP system, which is great, which is running great, as you can see here. At the same time, I want to do some kind of analytics, like I want to find out, okay, how many orders did I get on a particular type of item? How many orders did I get on a particular type of stock type? And how much quantity do I have? Because I'm getting so many orders and I'm accepting orders, do I have enough quantity to actually serve through? So I want to do a continuous monitoring of my inventory. To do that, I have a query here. And the first query I'm going to showcase you is actually by running how the query runs when there is a no special optimization has been done. It's a regular table. It has got regular indexes, and all you are doing is running some query on it. And that way, let's see this one. This part of the query will actually show us how much time it takes for monitoring my inventory. And as you can see, this is taking a few seconds. It will take a few seconds and then come back. Remember, it is taking several thousand milliseconds, like 3.5 seconds or so. And what we're going to actually do, we are going to actually create a non-clustered column store index on top of the table. This is how you create a non-clustered column store index. Pretty simple. And this non-clustered column store index will be used by this type of reporting analytics type of query, and thereby making it even fast. In this example, I had already created the non-clustered index before. That's why I had to use this hint that ignore my non-clustered column store index. So to give you a combined input, a combined experience of how this will work if I used both the queries side by side, let's take a look. So I'm running this query twice. Once normal, so optimizer will go and choose the non-clustered column store index because it exists. And another time I'm asking the optimizers to ignore the non-clustered column store index, and let us see how is the performance. And you can see with using the non-clustered, it's a 2 seconds. Without using the non-clustered column store index, it is actually 4 seconds. So the non-clustered column store index is actually giving you fast performance on top of your regular row store table. Now you can take a actually look at the execution plan. The first one is actually with the non-clustered column store index. And as you can see, the plan is much simpler. It has much less number of steps and is doing way more efficiently than the second one, which is actually doing a scan of the cluster index and thereby slower with respect to the other plan. So this is one type of analytics that people use a lot on their OLTP databases. Another type of analytics that is common is what is called window functioning. I'm trying to find out how many orders did I receive in last 15 minutes and break it down by either stock item type or category or time, any other dimension I want to break it down by. So if the old school way, if I did this query in the old school way, this is the query would look like. And it's going to take a bit of time because it is doing a common table expression with a join between table with a group by inside it. So it's going to take a bit of time. The new way to do is actually using the window functions. In Azure SQL and SQL Server, you can actually get a window function like this, and that is actually going to make this optimizer use this data to give you data much faster way. Let's run the query. Sorry, I have got it selected. Okay, as you can see, this can come back very fast, and I got my query run in actually 6 milliseconds. On the other hand, that without window function, that query is still continued running even after 48 seconds. So the window functions give you additional analytical query capabilities on top of your OLTP data. So that's a awesome combination to use. And now let's take an example of who is using it. As I mentioned, this is very popular, this kind of workload. Who is using it? ClearSale. ClearSale is a Microsoft customer based in South America, and they use operation analytics type of design inside SQL database to achieve what they provide actually a protection to their customer. Their customers are in fraud detection protection to their customer. Their customers are in retail, e-commerce, healthcare, and many, many industries. And all these have businesses. They run their business credit card processing through clear sale processing, thereby being able to do this fraud detection. So this is a very, very interesting example. Again, I encourage you to read the whole story in this link here. And also there is a video talking about how ClearSale uses our systems. Moving on to new type of workloads. Uh, some customer want to use JSON in their SQL database, and SQL database is very capable of handling JSON. Some workloads need graph capabilities. For example, you may want to find out relationship between connections between your customers, connection between your businesses and customers, connections between your various types of customers. And to achieve that, you want to build graphs on your existing relational data. So look no further. Azure SQL has fantastic relational graph capabilities. And some workloads you build mapping applications, and they built mapping applications using geospatial capabilities in Azure SQL. I encourage you to look at. We have actually published a GitHub repo of all these samples and examples, and I encourage you to take a look at those examples. Moving on to the next type of workload is for very large databases. As data keeps growing, whether through your IoT workloads or through your mission critical workload or through your SaaS applications or any types of application that when it is successful brings in more and more data. And so to sustain exponential data growth, you need very large databases. And Azure SQL is ready for it. But let's talk about some of the challenges that comes with very large databases. Very large databases come with interesting problems in the sense that many operations are function of the size of data. You want to move the database somewhere. You want to resize the database. You want to give more compute to the database. Whether you are scaling the data storage or you're scaling the compute, usually it is extremely complex, time consuming as the volume of data grows. Therefore, we took a fresh look into our database architecture and design. And what we built is a product called Azure SQL Hyperscale. Azure SQL Hyperscale is built on a new cloud-born architecture. It designed ground up using cloud paradigm so that it is fit for cloud workloads. What it does is that it decouples compute, storage, and log. These are the three main components of any database. It decouples them into three separate microservices. Each of them handle their own microservice and then talk to each other in a very coherent way. And thereby, each of these services can be grown independent of each other, which means that you can grow as much of storage as you need without growing any compute, or you can grow as much of compute as you need without needing any more space. So each of these way can be achieved through a very highly efficient way because what this provides is a memory hierarchy at three different layers. We have buffer pool, then on the compute we have a what we call a resilient buffer pool extension, which is local SSD. And there is another of local SSD cache, which is called page servers, which contains your entire database. You could have 100 terabyte database, and this page server will contain all 100 terabytes in a local SSD cache, thereby giving you very fast access. We won't have time to get into the very details of hyperscale architecture. I encourage you to actually go attend this session by my colleagues Bob Ward and Daniel Ribeiro. They go into all the gory details of how inside of an Azure SQL database hyperscale works. Interesting thing with hyperscale database is that you can also have many read replicas along with your primary compute, and you can use your client connection to those read replicas to get read scale. Uh, so what does hyperscale provide? Hyperscale provide you a 4 nines of availability with scale growth up to hundreds of terabytes and high performance through the memory hierarchy as I described in the architecture diagram. And it's a very suitable for VLDB workloads because you can scale each of the components independently. Let's take a look. When you have very large databases, usually people load data into the database. And as you know, uh, Azure SQL database is always running in full recovery mode. That's our way to give you protection against any kind of a user error, any kind of a service errors. Uh, mm, we run it in full recovery mode. Now, with full recovery mode, data loading may not be efficient, but I'm going to show you some tricks through which you can actually load data very efficiently into any Azure SQL database, whether it is hyperscale or business critical or general purpose, any tier. Let's look at, for this, I'm actually going to use a Azure Databricks cluster to read data from Azure Data Lake and load that into Azure SQL database. So I have a Azure to give you a um, data loading experience. Let's run it, and then I'm going to explain what is going on here. What is happening here is that, as I mentioned, I have data in uh, data lake, and then I'm going to use uh, Azure Database cluster to bring that data into a SQL database. What I have here is actually a heap table, which is the regular table. Heap tables are used for efficient data loading. And to load into heap in multiple parallel threads, I'm using tab lock equal to true. I'm using a large batch size to control locks, and I'm going to run this. And what this is going to do is actually start loading data. The job starts, as you can see, and I'm able to start loading data. When I start loading data, because of the full recovery mode, you can see that this is actually a Grafana dashboard, which is actually giving you a more kind of capability of view of how my log write is growing, how my CPU is growing, how my any weights, anything else that is happening in the system. What you will observe here is that because this is running in full recovery mode, a loading into a heap table will generate lots of log, and you can see here we are actually reaching very high log generation rate on this one. This blue line is the log write percent, and we are reaching very high 70-80%. What I'm going to do is actually because this is using lots of logs, generating lots of logs, this will be actually very slow. So I'm going to terminate this execution and then show you the better way to do it. Instead of loading into if you have to load large amount of data, instead of loading into a heap table or a clustered index, you actually create a clustered column store index. When you load data into clustered column store index, you generate lot less log, and thereby two things happen. Thing number one is that your resultant data is small in size, which is great. You are not occupying too much of disk space. Second thing is that it is efficient in generating less log, so your loading itself is fast. Let's see. Let's run it and then see how it goes. Uh, I kick this off. You can see the jobs are being started, and you can see that the new log generation here will be much less when the dashboard refreshes. You can see coming up. Okay, let's wait a second for the log graph to showcase. Okay, I'm using more CPU, which is understandable because I'm compressing while loading, which is great. But as you can see from the blue line, I'm not generating as much log as I was generating in the case of a heap data loading. So that's how you'll be able to load data fast into a column store optimized table in SQL database. So these are the few ways to optimize your workload and run your workload. And by the way, who is using hyperscale? Clearant is a customer which is in the banking sector, and what they do is that they provide credit card processing for their merchants, and they use in just hundreds plus million rows per month using a hyperscale tier of SQL database, and they use it in a way that many of the data has been consolidated into a data hub and providing a real-time operational data store. And this is crucial to their business because the credit card processing and operations depend on this system to be successful. I encourage you to read the full story about Clearant in on this link. Okay, as you can see, what the director of data management from Clearant is saying is that they have hit a sweet spot of concurrency and scale with the hyperscale service tier. You should leverage it if your application is a good fit. Okay, moving on. In summary, we saw various types of workloads. They vary from scenario to scenario. But the good part is that Azure SQL database is suitable for a variety of these workloads. What we call Azure SQL database is a battery included database. What it means is that um, when you buy a toy, if it doesn't have battery included, then you cannot use the toy till you get the battery. uh, Similar concept being used for SQL database. If you buy a SQL database, you don't have to actually wait for battery. It's battery included. By battery, we mean HA, DR, patching, security, all data kind of and very rich data modeling capabilities. All provided comes packaged with Azure SQL database. Therefore, your time to market for your application will be much faster. Your scale you can achieve through this database will be way better than other database services. The kind of performance for mission critical workloads that you can provide here will be fantastic. And I welcome you to try these type of workloads out and read the customer stories so that you can know who is using what type of workload. Here are some more examples of which customer is using what type of workload. I talked about gaming. Pearl Abyss is one of the gaming customers using SQL workload. We saw IoT. Interesting, I talked about graph processing. BKW is a energy a utility provider who uses graph processing to serve their customer. Esri is very popular for providing map applications, and they use special data types. Not to mention, many of our Microsoft first-party solutions are dependent on Azure SQL database. I would encourage you to take a look into some of the learning path material that we have provided in these links. There are tons of videos, tons of sample code, and lots of articles to ramp up on Azure SQL experience fast. And last but not the least, we have two awesome books coming up on Azure SQL, and they are available at PASS, and I encourage you to take a look at those. Okay, your feedback is very important, so please definitely go into the session evaluation link and provide your feedback. And you can reach us through various channels, including Twitter. So thank you so much. We're going to take a look into the chat window for any questions or any other thoughts that have come through you, and we'll try to answer them as we see. Thanks.